So moving on to our next session, I'm really excited about this next presentation that's coming up. I've heard fantastic things about the work that's been done around Public Health England's coronavirus dashboard. So without further ado, I'm going to hand over to Claire and Poria for the next session. Thank you very much.
Thank you. Thank you very much. Hopefully Poria is going to share slides. I'll just wait for that and then we'll get started.
Go.
Okay, great. Hopefully everyone can see that. So thank you very much for inviting us to come and talk to you about our work on the UK coronavirus dashboard. So I'm Claire Griffiths and I'm Head of Profession for Statistics at Public Health England. And I'm joined by my colleague Poria Hadjibagheri, who is the Tech Lead and Development Lead for the dashboard. On to the next slide. I think there might be a little bit of noise in the background, so if everyone could be on mute while we're talking, that would be great. Thank you. So this is what we'll cover in the session. It's a bit of an introduction, history of how we got to where we are, what the daily process looks like, and then I'll hand over to Poria, who's going to talk about the design and transparency, and then we'll have some time for some Q&A at the end. Okay, next slide. So this is just a quote from David Lamb, who's was a public health data manager in a PCT, talking about the swine flu epidemic and the availability of real-time data, where the situation back then was that really people were left to devise their own monitoring systems, and there was no real equivalent to the kind of dashboard that we've got now. And he felt that if something like the dashboard had been available then the epidemic would have been managed more efficiently. The next slide. So where are we now? So this is our service in figures. So the service is for the public largely. So we've got 750,000 daily users and 2.3 million weekly users with 80 million weekly page views, daily hits of 45 million, downloads of data at 1.3 million a day. And at the peak time of 4 o'clock, when we release the new data, we're looking at 100,000 concurrent users hitting that site. So that obviously presents us with some challenges, which Poria will go into in his section of the talk. But how did we get here? So these are some screenshots of different iterations of the dashboard. There was actually one even before the first version that you can see in the bottom right, which was a ArcGIS map of daily cases that we started up in March 2020. We were then asked to spin up a dashboard, and in April 2020, the first version was available, which had the 4 metrics: daily cases and deaths, cumulative cases and deaths for each nation, and a small amount of data available for England, regions and local authorities. We then moved on to the second version, which is the middle one in that set, which kind of looks a bit like slides, and that's because we were asked to expand the dashboard to take the place of the daily COVID briefings. They were happening every day at that point, with a lot of data being presented, and they were going to be scaled back, but the government still wanted the information that was being presented in those daily briefings to be made available to the public. So this version of the site was designed around testing cases, healthcare and deaths, and making available all of that information in an easy to look at and understand format. So we launched that in June, July time. I think it started up a couple of days before the press briefing stopped, and the Prime Minister tweeted a link to it, and our traffic went through the roof, and it's kind of stayed like that ever since. And then the final version you can see on the top left there is almost the current version. Actually, since we took that screenshot, it's changed a little bit in that we now have the vaccination data presented in a waffle chart across the top. But this version that you can see there, we launched in October, and this had mapping capability, so looking at data down to middle super output area level, which is very popular, and the postcode search, so people could find data local to them. Okay, next slide, thank you. So the daily process, just how do we do this every single day? And we have done it every day since we started, including Christmas Day, New Year's Day, etc. So the diagram shows workflow here. So I lead the team of analysts that start work at around 8 o'clock in the morning, kind of gathering data through the manual processes that we do, and also doing some QA and processing on the cases data that we get in around that time to make sure that it all matches up with the data files that other parts of PHE are using, and that process takes a couple of hours. We also prepare the MSOA data file at that point and send that over to Courier, and demographics data, so the age breakdowns of cases and deaths sent around 2:30. At around 2 o'clock, the data are published for Scotland and Northern Ireland, so we start working on some of their data, and Scotland's open data feeds are all refreshed at 2. So by 3, we've processed all of that, and over that goes to trigger the main data ETL, and that's processed and loaded into the front end database. We probably now, we have a little bit more time for QA than it shows on here, because these processes have been optimized, and we probably have about 20 minutes for final QA now, if everything goes well. Although I think it's fair to say that on most days, there's something that might cause us some issues. We're drawing in about 26 different data sources, I think, at last count. So with that and preparing all of the different outputs and so on from 4 different nations, it's perfectly possible that something goes wrong most days, but we do almost always make the 4 o'clock release date unless something's gone catastrophically wrong. Next slide. So this just shows the same thing that you've just seen, but just making it really clear that there is a separation of the data in the pipeline, which is on the NHS Foundry system, and the front-end database, and that's deliberate so that there can be no access to that pipeline by anyone external to PHE. Okay, so, I've mentioned the complexities already, but this just sort of puts that into some numbers. So I've mentioned the 26 plus data sources. That's more than 700 million raw figures processed every day into 10 million figures, popped over to the ETL, which turns that into 50 million. And then just some mind-boggling numbers really there on what data is in the main database, the age demographics and other demographics, MSOA data, with that total there over 5 billion records processed every day. So we'll just move on to the pipeline, which I mentioned. So this is a snapshot of our data pipeline where we process the 26 different data sources in the Foundry system. So it's color coded for our ease really of seeing where the different data sets are coming from. So the kind of purplish ones near the top are the healthcare data from NHS England. And we've got Northern Ireland, Scotland and Wales data. And below that, we've got NPEX data in a sort of corally pink. So that's a testing data set from NHS Digital. And then there's a pink one there, which probably is helpfully highlighted, which is the SGSS, so second generation surveillance system data from Public Health England that has the cases data. And below that is the deaths data from PHE, and at the very bottom is the deaths data that we get from the National Statistics Offices, so ONS, National Records of Scotland, and Northern Ireland Statistics and Research Agency. And then I guess just one final thing to mention on this pipeline is the light purple things at the top right are places where my analysts are manually sourcing data and entering that into the Foundry system on a daily basis. So this is just a little bit of a zoom in on the England cases pipeline. Each step of this is some Python code. And we have a team of pipeline developers, 3 of them who work on the pipeline day to day, fixing things that break, adding new data sources, adding new breakdowns. So, you may have noticed that we added vaccinations at local geographies earlier this week. So that's a collaborative effort between the people supplying the data in PHE, pipeline developers, analysts, checking and QAing all that, Courier's work on the database on the front end. So it's a huge piece of work to get something like that launched. Okay, we'll just go on to the next slide, which I think is the ETL. So ETL stands for extract, transform and load. So that's basically what this does to the data that is sent over. And I will hand over to Courier at this point for the rest of the presentation.
Thank you. Sorry, go back in there. Right. Hi, everyone. The ETL is a very complex piece of software that, in fact, started from a very simple entity. At the time that it was built initially, that was in April 2020, that is. We created it only to export CSV and JSON outputs for people who needed to download data. At the time, we had only 4 metrics, hospitalizations and deaths. Hospital deaths and cases. At that point, we just created a simple service that generated those files on a daily basis. Since then, this has increased in scope and expanded in scope and increased in size to do a whole lot of other things. And we've redesigned and re-implemented this thing many times to accommodate different things and speed it up, optimize it further. So right now it receives different chunks of data, if you like, on a daily basis from the pipeline. These are roughly the gist of it. There are more right now. It then splits these into a whole range of different properties and items. In some cases files, some cases service messages, and then submits them into our distributed computing system, where something in the scope of 90 different computers each containing 4 CPUs, so that's 90 by 4 instances, run these jobs at the same time. So when you see 6,800 jobs in here, that takes about 5 minutes to complete. If you were to run this on one single computer, it would probably take 2 days to complete. And then we do a whole lot of things. So we calculate the what we call derivative metrics, so rolling sum, rolling rate, trajectories, change, and things like that. We take care of what needs to be suppressed. So in the case of MSOA data, we suppress the data at a specific threshold, and that threshold being anything that is below 2, the rolling sum being below 2. So that gets suppressed for privacy reasons. So that kind of things also happen there. And then we generate daily reports that go to a whole range of different people and different organizations. And that happens probably 10-15 minutes before we release the data every day. So that's very important. In fact, I'll tell you why later. Yeah, then we do the QA. There are some automated QA processes in place that would cause the entire thing to break if something is not right. Then we consolidate certain parts of different data from different sources, and then archive them for future audits and deploy them to the to the database. There are a whole host of other things that are also done. So the map assets need to be regenerated every single day, and it can only be done at the time that we release the data. It used to take about 20 minutes. A few days ago, I deployed an update that reduced that to about 2-3 minutes. So now we have the map updated within 2-3 minutes of us releasing the data at around 4 p.m. The scales that you see on postcode page or on the map have to be also regenerated. So the numbers that you see here is a number of different assets that need to be created for each of these, and some other deployment jobs like download files, supplementary download files, the cache that needs to be refreshed, the timestamps that need to be updated, and things of that nature. Now, the design of this service is not as easy as it might seem to a lot of people, and there are a whole also host of reasons for that. Now, I usually interact with people, so feel free to just unmute and shout out the answer if you know. There is something wrong with this graph. Not very many people tend to notice it immediately. If anyone notices, please tell me. Now, if I go further, you can see that I've taken out England from the graph, and that gives you a clearer view of Scotland, Northern Ireland, and Wales, and the issue as well. And the issue has nothing to do with them being stacked or squeezed or anything like that. It's a design concept. If I go further, you can see this is now only Northern Ireland, and the color here is orange. So that is an issue because due to sensitivities in Northern Ireland, we should not be using orange for Northern Ireland. And these are the type of things that we need to consider before going ahead with a specific design. These are cultural sensitivities and things of that nature. So for that reason, we are using yellow. The reason that we are using yellow is that it provides us with sufficient contrast for people with color blindness and disabilities to be able to use the service, but it also takes into account cultural sensitivities of that nature. Other things such as expressions are also important. So you can see here it says people vaccinated first dose. That's a very simple thing to consider. I mean, this is from a previous iteration of the website, but nonetheless it is important because it has been carried forward. This took us about an hour of discussion, this simple line, and a whole number of variations were considered. You can see some examples of those in here. Now, the reason why we didn't go with there were different reasons why we didn't go with different options that we had, such as it doesn't define the dose, or it's potentially misleading, or it gives false impression that the person is now immune. If you say, people vaccinated without mentioning the dose, or it is too verbose for a headline figure. So this is just too long, for instance, people given first dose vaccination, or it gives impression that they have been offered but not given, which was an issue at the time. People were saying the statistics that were being published were about people being offered the vaccination but not being given the vaccination, which was completely false. The numbers that were published here, and this has been spelled out in the details of the relevant section, is about the number of needles that have gone into people's arms outside of clinical trials. So these are the type of things we also consider. Accessibility of the service is also important, and it is important for us to consider that one size doesn't fit all. So the structural hierarchy of the service is very important. We need to always be mindful of that, because screen readers can't understand, that there is a contrast here, or this font is larger if it is not in the correct context. It's not that the context is not correctly defined. These are not things that people who use the screen ever see, but they are there behind the scene. So there are contents associated with some of these numbers that you see here that are not even displayed at any point, but they describe, for instance, this graph. What is this graph? What is it showing? And where you can see the data for it. This is not something that we display, but it is something that a screen reader would read aloud for a person who can't see. Making the service accessible should not also mean that it is less useful to other users. So there should be a balance in there. We shouldn't, compromise. And it's always a work in progress. And it's not always also limited to people with visual impairment, people with dyslexia, for instance, or ADHD. They don't like very long paragraphs or long stretches of text. So we need to make sure that the width of the text that we are showing on the service is also reasonable, and things of that nature. We also keep improving the service. So then this is a heat map taken from the landing page, the homepage of the website yesterday, out of 90,000 clicks. What you can see here is that there is a pattern of people clicking in different locations. I mean, there are some clicks all over the place, but you could see that the red in here is usually where things are clickable. Something that we noticed in the midst of creating and improving this page is that people were clicking on the graphs here. These are not really graphs, these are thumbnails, because they don't really have y-axis. People were clicking on this expecting something. Now, whatever that thing might have been, they were expecting either to be able to zoom in or see the data for it, or something of that nature. We did have, and still do have, a link here that says all cases data, but nonetheless, people are clicking on this thing. So we made these clickable. Now, if you click on these, you will go to the same endpoint as all cases or all deaths data. So you will see more details, and you will have the opportunity to interact with the chart and see the data associated with it and things of that nature. So we routinely check things, improve things, and test it against different users and different demographics. Now, the transparency of the service is really important, and this is what I said I'll talk to you about later, and why that report that goes out around 15 minutes before we release the data is very important. That report contains the headline figures. So what you see on the landing page, nothing more than that. But this is what it means. It means that someone sitting at home in Newcastle sees the latest trends and graphs for the first time at 4 p.m. the same moment as Boris Johnson in his office in Downing Street does. That report, one of the endpoints for that report is the Prime Minister's office. So that is true. This is some next level transparency that is really, to a great degree, unprecedented in this country or pretty much anywhere in the world. So there are advantages and disadvantages associated with open data and this level of transparency, of course. The advantages is that it helps people understand government decisions. It justifies them. It makes the data accessible to millions of people, and it improves trust in decisions, in processes that are in place. And the fact that we can't really do it all, so no matter how good we are at what we do and how fast we do things, we still can't do it all. We can't possibly notice everything that goes wrong at every moment. And this interaction, this openness generates an interaction that we could of which we could take advantage. These italicized sections are kind of, double-edged swords of some sort. So rapid identification of mistakes and ever-growing demand for data. We'll talk about this more. And there are disadvantages associated with this. So there is room for misinterpretation. The more data you release, the more people have the opportunity to misinterpret them. There's pressure, there's a constant pressure to publish as soon as possible. So different things and different data as they become available, and that we have limited time to do QA. So we're talking about 50+ million records a day. There's absolutely no way to QA this entire thing, and it only takes one thing to be off, for us to end up where we don't want to end up in the headlines. So we have to have very robust processes in place, which mostly have been designed by Claire, to perform rapid QAs and identify issues of significance. There isn't really any room for delay. We have to publish at 4 p.m. We have the data sent to the ETL at the earliest at 3 p.m. So there isn't really much room here for maneuvers. So if something goes wrong, the likelihood of us having to delay the publication is quite high. We need to rapidly identify mistakes, and again, a very growing demand for data. So what does it take for a team to handle this? So this is about what? Nearly 300. This is from yesterday. 300,000 requests against the website per minute. So this aggregation is showing you per minute. 42 million over 24 hours. So when I say what does it take? What does it take to handle this every single day? So this is the last month. It doesn't change. You can see small spikes here. That's the 10 o'clock news. 1.3 billion requests in 1 month. That is a massive, massive volume of requests coming to our service. And it has consequences, of course. That massive spike is very difficult to handle technically. I don't want to go into too much detail because we're not really discussing much of the technical aspects of the service here, but it has been a challenge to accommodate that spike. Rapid identification of mistakes is as I said, a double-edged sword. We have 100,000 reviewers because we have 100,000 people on the website at 4 p.m. And our mistakes tend to be broadcast on national television within 2 minutes of us making that mistake. So you can see on this day, the service was updated at 4:04. It was on Sky News at 4:07. Literally, the landing page of the website was on Sky News at 4:07. Now, consequences, as I said. So on this day, we didn't have the data for deaths at the time we should have it. We should have it. So we decided to go ahead and publish the data at 4 p.m., leaving out the deaths data, and just for them to be published later in the day, probably around 8 p.m. We didn't want to make 100,000 people wait for 4 additional hours for a single metric. That had consequences. The consequence was that the data on the landing page showed the value as 0. But there was a big yellow banner, as you can see here, telling people that this is not the correct value, except they didn't check it because they were using the API and they saw a number showing it 0. They didn't go to the website to check whether or not this is the correct value. They just went ahead and launched breaking news campaigns all over the place. Now, some of them saw this and corrected it pretty quickly, but some of them I just gave up on after 5 hours. So this is also a consequence of different decisions that we have to make. So these are judgment calls we have to make. So some people complain that you don't have to keep us waiting until 8 o'clock in the evening if one metric is missing. Sometimes we have to do that because a whole lot of other metrics depend on it. But sometimes we could go ahead, but us going ahead has consequences. So vast majority of users tell us about a possible problem and we fix it. So if they identify an issue, they tell us about it and we fix it as soon as we possibly can. Minority of users try to catch us making mistakes to either ridicule or justify an unfounded theory or something along those lines. I mean, there are different ways of looking at this. They're both our users at the end of the day, and they make equally important points, just make it in different ways. And they have equal rights to see the data, and they both deserve to be heard, whether they're ridiculing us or whether they're just trying to help. So one way to look at this would be that they provide us with a unique opportunity to inform the design of user research sessions. So next time we are trying to implement something, we could use that information to look at certain aspects of our design that we hadn't thought of before. It helps us improve the robustness of our SOPs, so that our standard operating procedures that we use to create or release the data, or do automated QAs and things of that nature. Improve the QA process that we have, so we could change the QA operating procedure to accommodate additional checks, and we can improve the design to mitigate misunderstandings. So given that this conference is for analysts, I have also put here a diagram, a UML diagram of our database as it currently stands. For people who are interested, this is showing a Snowflake schema in which you can see the star in here. So going out to 3, and then each of these go out to additional additional tables, creating a Snowflake. And yeah, it's a fully relational database, but it does have non-relational properties as well. And we try to maintain the integrity of this database as much as we can, which is why we don't repeat things. We always use foreign keys to make sure that everything is as robust as it possibly can be. And there's an ever-growing demand for data, as I mentioned earlier. I mean, we currently have 44 active metrics for deaths, of which 40 are live. So 40 have been published, 4 are under development, and 6 have been deprecated. Now, this is important because we, no matter how many of these we publish, we keep getting requests to publish more, and there are always, critical reviews of different parts, different metrics. Some of them are perfectly justified as well, but nonetheless, we have to work with what we have, and we keep trying to make things available as much as we can and as soon as we can. Open data prompts trust, and that is very true. Openness in general prompts trust as well. You could see that the this is trust level in our service in general. In August it was about 63%. In November it was 78 or thereabouts, and in February, our latest survey, it was 91.5. So it's increased over time, and that is in part because we are trying to be as open as we possibly can. We also try to interact with people via our email, through Twitter and social media, and we try to help them. So we respond to them, we take into account their views, we ask them questions when we are trying to come to a decision on, say, a visualization of some sort, and things of that nature. And people tend to respond to that quite positively. And as I said, we can't possibly do it all. So an example of that you could see here is that the people come over to the website, download our data, and create their own services and visualizations. And then those are quite interesting. So these are animations that people have created using our data, and they're quite popular, some of them, and they're very interesting. But we can't possibly put them all on the website, or we don't also have time to create them all. You can see an example of this. Quite interesting. It also promotes collaboration. So, there are websites that have been launched and created to display the data in different ways, aggregate them. An example of that would be this website. There are news outlets that regularly use our API to publish data in different ways or analyze them. Financial Times, Sky News, BBC News, they have postcode search and things of that nature, which uses our API directly. There are international agencies that use the service, such as WHO, researchers from Imperial, Hopkins, Oxford, Cambridge. They use the data to create models or do their analysis. And there are national organizations that use the service to obtain consolidated data, such as JVC, local authorities, the military. Different organizations use the API, which is public. Anyone in the world can use it to do their own analysis and help their own work. It's also about, helping people. We've had people tell us that they use our service to make decisions on a daily basis. So they use it to decide whether they should go to the barbershop to have a haircut, or plan their business activities, or visits or vacations. So an interesting anecdote of these business activities is back in December, there was a chap who told me that he was using, he noticed that the cases were going up at the time, and he predicted that there will likely be a lockdown soon. On that basis, he changed his stock orders. He runs a chain of restaurants across the country. So he adjusted his stock and the orders he placed to account for that, and reduce his loss, and in so doing, he managed to actually get it right. So we did go into lockdown, and he did prevent an otherwise substantial loss. We also, our service is also open source. So our entire code base is available publicly through 18 public repositories. We have worldwide contributions. It helps improve transparency and elevate trust, because people can see how we handle the data and publish them. It improves our security, because we do get security advisories. People can see them. If they notice a mistake, they can highlight that. It does increase the need for maintenance, and that is also a double-edged sword, because it kind of takes more work to maintain them and make them presentable when they're in public domain. They need to be in a more presentable structure, but it also is an advantage, because it means it will be more maintainable as well in the future. The disadvantage is that they report issues with data in the repository, which is unrelated to the repository. It has to go to the data team, or it also increases, as I say, the need for maintenance. This is an example of a global contribution. When we released this section for vaccinations, which was a couple of weeks ago, there was a mistake in the tooltip of the percentage, the percentage for second dose, in which case it was just saying first dose instead of second dose, as you can see here. And two people actually noticed that, and they both separately created a fix for it. So went to our code, found where the problem is, changed it. You can see here, first to second. Submitted their changes. Say they created a pull request, submitted it. I was notified of the submission. I reviewed the submission, approved it. It was added and deployed to the service within hours, and the problem was solved. Now, if it was down to us, we might not have noticed it for a week. So the fact that this was open, or even if it noticed it, it had to go into the backlog for me to get there and fix it. But this is open source. Anyone can fix it. They fixed it. We approved it, and that was that. So concluding remarks is that where are we going from where we are? When I finalized this slide, these set of slides for this talk, we hadn't done this yet. So that was, I think, on Friday. This was deployed the day before yesterday. So this is now done. We are now working on vaccination demographics. vaccinations at MSY level, local tests processed, and possibly variants. And we might get to do things that we don't even know about yet because they haven't happened, because that is how this thing works. So I said we started with 4 metrics, increased to 8, increased to 50, increased to 90. Now we have 205 metrics across over 8,000 areas in the United Kingdom. And some reflections here. So, there are things that we can do better in the future. We can have agreement between responsible parties and organizations so that we don't have to reach one in the middle of a pandemic to obtain data or publish data, how to publish them, when to publish them, things like that. We need to have defined measures to break ties in specialist domains. So different people who specialize in a domain may not necessarily agree with each other on how X needs to be calculated. There needs to be something in place that breaks the tie when someone from one organization or one nation says something, someone from another says something else, someone in the middle needs to have the final word. Independence and impartiality is very important. So it would be useful to have an organization that focuses on data science, and possibly an institute of open data or data science in government or something like that. That is independent, it is impartial, it is not the ONS, and yeah, it would be quite useful to do that. Why it is not the ONS? Because ONS is one of the sources of data, and that means that we can't have this with one of the sources of data at the same time. Expertise in handling large volumes of data, so existing expertise. We were quite lucky to have the right people in the right place at the right time. There were 4 of us in the beginning, and that is how this dashboard came to be. So that was quite, it's a stroke of luck, basically. That should not really be the case. We need to have people with the right expertise in place who can do this, and people with domain expertise. So in this case, it would be epidemiology, and in some other case, it might be some other thing. But we should have these people in place in an organization ready to be deployed. And finally, we should really thank all the organizations who have helped us create the service, supplied us with data, help us every day to make this thing possible. From the current and former members of our team, Public Health England, different parts of Public Health England, NHS England, NHS Arden GEM support unit, Test and Trace, DHSC, National Statistics Organizations, Devolved Administrations, Palantir. We work with the NHS and our pipeline, and Microsoft and Microsoft Azure support team, who've been very helpful on different, helping us with different aspects of our infrastructure. And last but not least, and probably one of the most important ones, is the analysts, without whom none of this would have been possible. They work every day and they help us, bring things together, and they are in the background, and they should not be forgotten. Thank you.
Right, thank you very much, Claire and Puria. Great presentation there, lots of claps going on, thank you. There are some questions. I unfortunately can't see the chat, so somebody's kindly text them through to me, so I don't know who's asked them. One thing I did like about your presentation that you pointed out, the visualization, so important, and one of those things that we have to be so aware of, and we do it all the time in our day-to-day jobs, making sure the visualizations fit for purpose, the headings are legible or understandable, which is bad enough when you're doing it for an organization, but when you have to accommodate the requirements of an entire nation, that's a whole different ball game. So questions being asked. You finish off there, Puria, by thanking all your analysts, and one of the questions was, how many analysts are in your team? How big is your team?
Claire is best placed to answer that also.
How many analysts are in the team? So there's 5 analysts in the team, permanently attached to the team. We also have analysts on loan from other teams. In total, I think the dashboard team now has 22 whole-time equivalent posts allocated to it in PHE. Not all of those posts are filled at the moment, some are vacant. So I mentioned 3 pipeline engineers, for example. I think the other thing to remember, of course, though, we're just the people pulling it together at the very end. I think what Puria was kind of getting at is that, you know, out in the NHS, there's analysts in every trust, making sure that the data that ultimately ends up on the front page is all in order, and it couldn't be done without that. So the actual kind of resource that goes into making something like this available is absolutely huge, very difficult to estimate, I would say.
Excellent, thank you. Yes, I suppose, like you say, 26 odd data sources, 5 billion data items a day. Yeah, huge amount of work going on in the background. Another of the questions that came up is, what technology do you use to do the ETL process?
So the ETL process is, the code for it is written in Python exclusively. However, the database parts of it are, of course, in SQL. The service itself runs on serverless infrastructure, on something known as orchestrated serverless infrastructure. So we have a coordinator node, if you like, and then that coordinator node communicates with worker nodes that are launched or are basically ready to go, and then it takes the outputs from them and consolidates them or submits them to subsequent worker nodes. So it's a combination of infrastructure design and code.
Thank you. Another question that's come up. On one of your charts, you showed the different little trend lines, and you could see where people had been clicking on them. So you changed, you know, made your charts interactive. How did you actually get the feedback on those clicks?
So there are different services available for that. There is one that we use from Microsoft that provides the service for collecting click events on different locations on the website. But we do also have bespoke event recording systems that send aggregates to our storage, and we also combine these with our Google Analytics data and create aggregates that provide us with different types of insights for different events, including clicks and click regions.
Okay, thank you. Now, as I say, I can't see the chat, so I can't see if any other questions have come up in the chat. If anyone has another question, do you want to raise your hand and we can pick it up from there, or is that it? Oh, Zoe, is that Zoe?
Hi, yes, I did ask in the chat, but you can't see it. I just wanted to know how you, hello, by the way, because I kind of stalk you on Twitter. Oh, so good to see you. I just wanted to ask about the thing with the Northern Ireland. How did you pick that out? Because being so England centric completely missed me, and I just feel like, how do you do that? How do you have somebody on the team who's from Northern Ireland and went, no, don't do that?
No, I noticed it.
Fantastic, well done.
Yeah. So in parts of our review for design back in, I think it was May, quite by accident. So we have a predefined list of colors that people, so the layouts of the charts and data that you see in details pages, not in the landing page, details pages are created separately in YAML files, which are then converted to JSON files. They're all publicly available in GitHub. So these are a bunch of instructions, essentially, a structured set of instructions that people who have the right to change that repository can write or change, that will make things appear, disappear. It gets connected to our API, pulls the metric, displays it using the chart you've defined in that layout, the color that you've defined, the type that you've defined. And the way that the colors are defined is that they're predefined and they have a number associated with them. So the person who is doing this needs to, when you have a stacked chart, you do high contrast, low contrast, high contrast, low contrast. And by accident, the person who was doing that at the time, when we were testing this before it was deployed, had selected a color that landed orange in there. And when I was reviewing the work and working on it at some ungodly hour, probably 2 o'clock in the morning, I noticed that this is not right. This is orange. It can't be orange for Northern Ireland. And I mentioned it the next morning to colleagues, and we took measures to ensure that doesn't happen. So this was an example of the type of things that we need to be very careful about. It doesn't always immediately, manifest itself. We might even deploy that and not get many complaints about it, but it has. These things tend to have consequences in the long term, and we try to be mindful, or even if we don't notice it immediately, we change it as soon as we notice it. And by that I mean there have been cases that we've changed things within minutes of being made aware. And doing that type of responsiveness also tells people who tell us those things that they are genuine mistakes. If you go through a review that takes 2 months, that's not going to cut it for a lot of people. The fact that we do these things quite rapidly is also reassuring.
Thank you. That's great, Puriya. Right. Thank you again to Claire and Puriya for an excellent presentation. Really interesting stuff. We now have lunch break, and during lunch, the same chat rooms that we had before, our machine learning and professionalism are there, but the links will be different to what they were this morning. So your link for our chat room is different now. I'm assuming, because I can't see the chat, that the new links are now in the chat. Oh, yeah, I've got thumbs up there from people. So those chat rooms will be open now until we restart at 2 o'clock to see some members' bits and pieces going on, and some of their showcasing of their work, awards, etc. So see some of you in the chat rooms and see some of you after lunch.